Welcome to the farthest reaches of the universe, where, far away from Earth, Saturn spins silently, surrounded by its retinue of mysterious moons. Yet among these companions, Titan stands apart, a riddle in the night sky, an enigmatic melody that scientists cannot resist. What is it that makes Titan such a singular, mysterious being among the cosmic orchestra? Why does it forever draw humanity's gaze, brimming with curiosity and longing for discovery? Have you ever wondered what kind of satellite is so steeped in secrets it deserves its own documentary? In today's video, we open the gateway to this mysterious world, where Titan wraps itself in a dense, almost mystical atmosphere, where the surface shimmers with colors, captivating liquid, oceans that echo with silent beauty, where the landscape is so eerily Earth-like that it almost feels like a memory from home, where warm rains fall, drop by drop, as if the breath of life itself is whispering down. And finally, a form of life exists here, one that not everyone can dare to imagine. What do you think it is about Titan that has captivated the minds of scientists, sending them on a relentless search for every fragment of its mystery? We let our hearts beat in time with those questions, digging through every bit of information we could find on Titan, determined to fit all of it into this one story. Titan, resembling a young, cold Earth from long ago, stands as an open invitation for anyone ready to dive into the wild, unspoiled heart of the cosmos. Did you know, among Saturn's 63 known moons, Titan immediately seizes the spotlight, a giant in a cosmic choir. With a diameter stretching to 3,200 miles, Titan is even larger than Mercury, only a fraction smaller than Mars. Will you join me on this journey to unravel the secrets of Titan, where every hidden wonder is waiting for you to pull back the curtain? Although its massive size means that any amateur astronomer can gaze at Titan with nothing more than a simple telescope. For centuries, Titan remained a puzzle, wrapped in layers of cosmic silence. Did you know Titan was first discovered back in 1655, when astronomer Huygens noticed a strange object drifting beside Saturn? It had actually been glimpsed before, but was always mistaken for a lonely star wandering the cold stretches of space. Titan's first earthly visitor was the Pioneer 11 probe, followed later by Voyager 1 and 2, which swept past and snapped fleeting portraits of this distant world. Yet those first images, like blurry fragments of a forgotten dream, revealed little about Titan's true nature, except for one bizarre detail: a haze so dense it veiled Titan from humanity's eager eyes. Then, scientists realized that this haze was not a simple shroud, but a tapestry woven in layers, its uppermost sheet made of hydrogen and nitrogen. Even the mighty Hubble Space Telescope couldn't pierce Titan's secret curtain. Each attempt fell short, the mystery only deepening. For a while, it seemed the story would end there, until a visionary voice rose above the silence. Carl Sagan, an astrophysicist, a storyteller who ignited the curiosity of millions. It was Sagan who suggested that if Titan's surface temperature was minus 290 degrees Fahrenheit, then methane, so familiar to us as the blue flame on our kitchen stoves, would become a liquid, spreading across the world in vast alien seas. Have you ever imagined such a place? A world where oceans are not made of water but of liquid methane. If you have ever kindled a gas stove, you know methane's gentle, flammable breath. Now picture a realm where methane flows in rivers, tumbles from the sky as rain, and carves icy plains with its touch. Would you ever wish to stand beneath that methane rain, to listen as it taps against a world so far from our own? Those methane rivers don't simply stop. They surge onward, pouring themselves into gigantic, unfathomable methane seas, sowing seeds of mystery all across Titan's surface. In 1997, the Cassini spacecraft set sail from Earth, bound for Saturn on a mission not just to unravel the secrets of the gas giant, but also to explore its silent, swirling moons. Although Titan was never meant to be the star of this voyage, Cassini carried a special child, Huygens, a tiny lander cradling humanity's wildest dreams. In 2004, Huygens broke away from Cassini's embrace, plunging toward Titan's strange world. Sadly, almost half of the precious data recorded during its descent vanished into the silence of space. And yet we were gifted the chance to witness this remarkable odyssey as Huygens bravely pierced the shrouded atmosphere. The descent itself lasted 2.5 breathless hours, a journey through layers of wonder. Titan's atmosphere proved so dense that Huygens had to float down by parachute, tossed off course by fierce winds, spinning so wildly that many images captured along the way were hopelessly blurred. Could you feel the tension in that descent? But it was this journey that unveiled Titan's atmospheric secret. Its shroud rises over 300 miles above the ground, a record-breaking height in our entire solar system. Titan's sky is divided into distinct layers, each one unique in its chemical makeup and temperature. While the ground freezes at -290 degrees Fahrenheit, up at 200 miles, the air is warmer, only -130 degrees. Can you imagine? At the very top, Titan's sky turns a deep blue, ruled by nitrogen and hydrogen. But at about 250 miles up, that mysterious orange haze appears, unfurling a curtain of secrecy that drapes all the way to the surface. Are you ready to step through that curtain of haze and touch Titan's hidden heart? On the long descent to the surface, that thick orange haze only begins to thin at around 60 miles up, finally clearing as Huygens draws near Titan's mysterious ground. At about 30 miles above the surface, human eyes first catch a glimpse, like drawing back the curtain of a long-hidden stage. And what appears is hauntingly familiar. A landscape dotted with mountains and the ghostly traces of rivers. As Huygens touched down, scientists found the orange haze to be strikingly uniform, an unbroken shroud through which sunlight barely ever reaches the ground. On Titan, even at noon, the sun is nothing more than a pale, distant specter, a morning without clarity, a day that never quite wakes. The surface, though textured, remains mostly flat, its highest peaks rising just 0.6 miles. Soft breaths amid a frozen expanse. Take a look at the first image Huygens sent from Titan's surface. Chances are, the craft landed in what was once a riverbed of methane, now dried and empty, leaving behind smooth, rounded pebbles like memories of flowing tides. Those stones may have lain there since the river was still alive with cold methane, enduring through ages of silence. And yet, there was no sign of liquid anywhere. Where had those fabled methane rivers gone? After the landing images were processed, some were woven into a stunning collage, revealing a tangled web of river systems, branching and dividing in a way not so different from rivers on Earth. This vision sparked countless theories about the fate of Titan's vanished liquid methane. And if it were you, how would you feel standing in a place both familiar and strange, where the past and present seem to breathe together in the shroud of an alien dawn? The first theory sounds almost earthly in its simplicity. Titan, too, is swept by the cycles of climate. Rivers fill with methane rain as storm clouds gather, then dry up again as the seasons shift, leaving empty channels beneath the eternal mist. The second theory, more daring, suggests that those methane rivers once drew their lifeblood from underground springs, secret veins hidden deep within Titan's frozen heart. For reasons unknown, these hidden springs may have run dry, and the rivers faded into silence. Which would you believe? A Titan awash in endless rain, or a Titan hiding lost streams deep below the ice? Meanwhile, Cassini pressed on, looping again and again around Titan, planning 127 flyby missions to peel back the layers of its mystery. Thanks to a single photograph of the atmosphere taken by Cassini, scientists finally began to untangle why Titan is so completely shrouded. Did you know Titan's atmosphere is a symphony of layers, like the greatest cosmic factory ever built. At heights over 300 miles, sunlight strikes methane, nitrogen, and hydrogen, transforming them into complex organic compounds, the very first bricks in the wall of Titan's unique life story. These new molecules drift downward, creating yet another layer in Titan's celestial cloak. The second layer lies between 200 and 250 miles above the surface, a haze of tholins, a substance not so different from the soot that rises from earthly fires. The third layer starts around 200 miles up, composed of the inner gas ethane, like yet another curtain drawn across Titan's sky. Have you ever wondered just how much light and how many secrets are swallowed by these endless veils, each hiding Titan's true face? Here, scientists observed a rare phenomenon, a true anti-greenhouse effect. On Earth, atmospheric gases trap heat and warm the surface, creating the greenhouse effect. But on Titan, everything is flipped upside down. The tholin haze and ethane together form an enormous shield, blocking the sunlight, holding a bit of warmth high at 250 miles up, while near the surface, the cold still reigns at a bone-chilling minus 290 degrees Fahrenheit. At around 60 miles above, Titan quietly cradles a few rare clouds, drifting slowly in a sea of thick haze. And though Titan's climate changes faster than anything we know on Earth, sometimes the cosmos gifts this moon with truly wild moments. Just recently, a real tropical methane storm was captured right at Titan's equator. The image from Cassini revealed a storm shaped like a massive arrow, stretching over 200,000 square miles. Can you imagine it? Methane raindrops, the size of pears, falling so slowly from the sky you could simply step out of the way. A kind of rain never before seen on Earth. Thanks to Huygens and Cassini working together, scientists were able to confirm the composition of Titan's atmosphere. Much like our own world, Titan's air is mostly nitrogen. But here's the twist. It also contains 3.5% methane, a detail that, if you're as fascinated by the mysteries of the universe as we are, leave a comment sharing your thoughts, drop a like, and don't forget to subscribe to our channel for more cosmic journeys. Who knows, maybe your idea will inspire our next adventure to Titan or beyond. Let's spread the passion for discovery together. But that wasn't the part that truly astonished scientists. On Earth, and most other planets, chemical reactions take place near the surface. Yet, on Titan, the chemical reactor is set high above, at an altitude of 300 miles, where sunlight and molecules collide to create a cascade of organic compounds, falling steadily to the ground like a never-ending chemical rain. Over 4.5 billion years ago, Earth was just like Titan. The only difference was that Earth was warmer, thanks to its closeness to the sun. Back then, the organic matter that fell from the sky didn't vanish into a surface of methane soot and icy rivers, but mingled with oceans full of water. After studying the composition and layers of Titan's atmosphere, scientists stumbled into another riddle. It turns out the methane now present in Titan's atmosphere should have disappeared just 10 million years after it formed. Yet billions of years have passed, and methane still lingers, perfectly balanced, a challenge to the passage of time. What is fueling this endless source of methane? Some scientists propose that from the very dawn of Titan's birth, it held a massive reservoir of methane, enough to last to this very day. Others suspect that strange, hidden chemical reactions are still at work on Titan's surface, even whispering about the possibility of living organisms. Secret chemical artisans quietly sustaining Titan's skies for billions of years. If this question were placed before you, would you believe in a hidden reserve, or dare to imagine a life form unknown to our world? Another, even bolder theory was born. Perhaps primitive life forms, if they exist, produce methane as a natural part of their life cycle. This was the first faint hint, a glimmer of hope, that some form of life, however basic, might one day be found on Titan. The next riddle that troubled scientists was the amount of hydrogen in Titan's atmosphere. Calculations showed there should be 2.5 times less hydrogen than what was measured, and its distribution was curiously uneven. Near the surface, there was much less hydrogen than expected, while closer to the top, there was nearly twice as much as the numbers predicted. This led researchers to consider whether biological processes might be at work, drawing hydrogen down to the surface, creating an invisible shortage. With these questions still unanswered, let us turn our attention for a moment to Titan's surface, where a new tapestry of mysteries awaits. Take a look at this image, captured by the Huygens camera, an artist's approximation of what the surface might look like to human eyes. Astonishingly, it looks eerily similar to our own Earth. The next images, even more detailed, only heighten the sense of déjà vu. The radar topographic map makes it seem as if we are gazing at a familiar landscape from home. It is also worth noting that Titan's surface bears remarkably few meteorite craters, the largest of which is called the Minerva crater. The Minerva crater spans an immense 500 miles in diameter. Yet strangely, there are far too few craters on Titan's surface. The answer may lie in its incredibly dense atmosphere, where anything small simply burns away long before it ever touches the ground. Even so, there are still too few, and this scarcity presents a challenge for scientists. Without impact scars, it's almost impossible to estimate the true age of Titan's terrain. As a result, no one can say with certainty just how geologically active Titan is, or whether it possesses tectonic plates like our own Earth. In fact, its surface is so suspiciously smooth. It's as if the hand of time has gently erased every trace. Now imagine Titan stripped of its ethereal atmosphere, revealing dark regions that once stirred great excitement among scientists. Initially, it was thought these were the legendary methane oceans. But when Huygens touched down in one of those shadowed areas, it found no liquid at all. Upon closer inspection, it turns out these dark spots are actually vast deserts. When compared with deserts on Earth, the similarities were uncanny, formed by processes almost identical to those that shape our world. Thanks to Titan's unique climate, with its own seasons and ever-shifting winds, dune systems made of tholin soot and organic compounds have formed across the landscape. But on Titan, with its low gravity, a mere wind of 11 miles per hour is enough to unleash swirling dust storms, sculpting the alien sands into ever-changing patterns. Can you picture such a strange and familiar wasteland, where wind, dust, and time weave a mysterious symphony on a world far from our own? Although the sand on Titan is organic, unlike the mineral grains on Earth, scientists are still searching for an answer to what truly created it. At first, it was thought that Titan's sand formed from the remnants of methane that rains down from the sky. As liquid methane descends, it carries tholin soot from the atmosphere to the surface, and when the methane evaporates, the residue left behind becomes the sand. But rain is rare on Titan. So now, the leading theory suggests that this sand simply falls out of the tholin haze, drifting gently down to the surface like alien snow blanketing the lonely satellite. After studying those first pictures of dried-up riverbeds, scientists set out on a new quest to find the missing liquid. Their search led them to discover Titan's first methane lake, Ontario, resting at the moon's south pole, the only lake left in that region. Yet all around it, the ghostly outlines of dried-up lakes could still be seen, like ancient scars in the frozen ground. Debate continues over what lies at the bottom of these lakes, and what the mysterious shores are truly made of. Meanwhile, at the North Pole, entire methane seas were soon discovered, fed by winding rivers in a world turned upside down. Kraken Mare and Ligeia Mare, vast and singular, stand out as unique treasures in our solar system. For this is the only place beyond Earth where liquid has been found on a surface. Yet, the greatest mystery remains. hanging unanswered in the Titan air. The biggest and most haunting question remains: can this distant satellite truly sustain life? There are two paths to consider. If we use the conditions we know from Earth, there's a crucial fact to pay attention to. Scientists have discovered cryovolcanoes on Titan's surface, where liquid water erupts from cracks in the icy crust. This means that beneath Titan's frozen exterior lies a hidden ocean of warm water, sandwiched between two layers of ice above and below. A cosmic sandwich, cradling secrets in the dark. Thanks to Saturn's powerful gravitational pull, this hidden ocean rises and falls, not only warming the waters, but also fracturing the outer shell. Water, mixed with abundant acetone, bursts onto the surface, mingling with the organic sand that drifts down from the sky, together creating conditions on Titan's surface eerily reminiscent of those on early Earth, 4.5 billion years ago. The only difference is that Titan sits much farther from the sun and is far colder. That's exactly why these processes fascinate scientists so deeply. For maybe, just maybe, they hold the clues to understanding how life first began on Earth itself. The other theory, however, is life according to Titan. It would seem that in such a frozen, hydrocarbon-rich world, without oxygen and without water as we know it, life could never exist. Or at least, not life as we understand it. If you were standing at this crossroads, would you believe in Earth-like life? Or would you dare to imagine something entirely new? Life beyond all the boundaries we have ever known. Indeed, the surface of Titan is nothing less than a frozen gasoline lake, chilling and utterly alien. Yet, even in such an unlikely world, hope for life persists. Scientist Chris Mackin once suggested that methanogen bacteria could exist on Titan, just as they do on Earth. These bacteria feed on hydrogen and acetylene, thriving in the chemical sea and producing methane as part of their life's work. This idea could explain why there's so little hydrogen near the surface, and why methane is always so abundant in the atmosphere, even though it should have vanished long ago. It seems as though this could finally be the answer to Titan's greatest riddle. And yet, a problem remains. Methane and ethane are not like water when it comes to supporting life. Water is an excellent solvent, allowing microorganisms to rid themselves of waste and dissolve toxins. But methane and ethane, in both liquid and solid form, are not suited to the critical work of a cell membrane, the fragile boundary that filters and shields life's spark. More recently, however, Chinese scientists have managed to synthesize azotosomes, organic compounds that could form a protective membrane for cells existing in such an extreme environment. There's reason to believe this kind of membrane could form naturally in methane and ethane seas on Titan. Additionally, observations made through the ALM telescopes in the Mexican desert have revealed telescopes revealed that there is, in fact, a substance on Titan, precursor to those azotosomes, that could protect a living cell, and in such abundance that up to a quintillion organisms could thrive within just 10 square feet. Any arguments denying the possibility of life in a methane world were further silenced by the discovery of an unusual asphalt lake here on Earth. This lake is made almost entirely of natural asphalt, petroleum, and countless complex hydrocarbon compounds. Samples taken from its depths revealed millions of ancient anaerobic bacteria, alive and well, thriving in this chemical world. These resilient life forms feed on hydrocarbons, breaking down crude oil with remarkable efficiency. Though it's true that Titan's temperature is far colder than Earth's, and its chemistry unfolds at a slower, more deliberate pace, the chance for life on Titan is very real, and might even be as astonishingly diverse as the earliest life that once emerged on Earth 4.5 billion years ago. Just imagine a hidden world, life thriving on the surface, or perhaps diving deep beneath the ice into a warm, subsurface ocean. All that we, and the world's scientists, can do is wait for the next mission to Titan, to bring us ever closer to the secret of how life truly begins. But right now, you, like thousands of other dreamers, can raise your telescope to the sky and study Titan, that cold but living mirror of Earth's own past. If you're as fascinated by the mysteries of the universe as we are, leave a comment sharing your thoughts, drop a like, and don't forget to subscribe to our channel for more cosmic journeys. Who knows? Maybe your idea will inspire our next adventure to Titan or beyond. Let's spread the passion for discovery together.